Hello, welcome everybody. Today we will have one more set of problems and solutions. This is part 4 in the series. We had three previous set of problems and solution. We are having a fourth set where we will be dealing with different types of problems, like say the non-linear break-even analysis. This is one, and next we will do the a set of problems merged together to demonstrate the depreciation of assets. How do they behave when we plot them one against the other? As you can see from here, just to remind you or let us recall about the break even chart, which is linear. In this particular slide we are showing the linear once again, just to set the mood rather, and then what complications can arise from the total sales and total revenue if they are not linear. So, from the linear chart, what you can see here, that this line is horizontal line is showing you once again the fixed cost, and then there is a variable cost which when added with the fixed cost gives you the total cost. Because this is already having this has touched the fixed cost, so the whole thing is drawn like this, and this shows you the total cost. So, this part, the difference is variable cost wherever you plot. So, this lower part is the fixed cost and the upper part is the variable cost. Total if you add, then we get the total cost, and this is starting from 0, this is the total revenue, sales revenue. Okay. So, we have plotted this total cost versus total sales, and we found where these two lines are intersecting, and we call it BEP or we call it break even point. Now, the question of profit and loss lies very simple. You can demonstrate with reference to the break even point. So, on this side wherever you are above the total cost, and you can see how much profit you are making. At the same time, if you are going the left side, then you see this is the difference between the total cost and the total revenue, which is going like this. So, the revenue is less than the cost, so you are in a loss. That means this shows simplistically where you are in the profit zone or loss, and how much is the margin of safety, which we have discussed. Now, in practice, except in very small business, this linear charts, break even analysis, linear analysis does not hold true. This is much more complicated, because even the fixed cost will not remain fixed cost when the the volume of production increases very high. At the same time, the revenue and the first thing, the variable cost, that will also change. So, some per unit rupees per unit variable cost will not hold true. When you go for higher production, you will see that with the same variable cost you can produce a little more, but when you go further high, then the variable cost will not remain same, then you have to add. So, this linearity will not remain. So, what we now try to solve is non-linear equations, which we have seen earlier in the theory part, and we are again demonstrating with one more example here in detail, that how we can tackle this situation where the neither the revenue nor the cost is linear. In this example of non-linear break even analysis, you can see that the relations in both the cases are not linear at all. So, for example, the revenue function here is given as Gx, which is a function of x, that means the number of units produced is 4 into 10x minus x square whole divided by 25, whereas the cost function denoted by the hx in $1000 again is x cube minus 12x square plus 50x plus 100 whole divided by 50. In both the cases, these two are not linear at all. What we have to find out? That we have to find out the break even production, number 1. Where do we break even? That means the break even point rather. Then on the profit side, if you go, then you have to find out the maximum profit production. That means at which number of units will give you the maximum profit, and the quantity of maximum profit. That means the amount of profit, maximum profit that you can earn when these two equations hold true. Now, to find the break even point, we have to calculate the profit. First, we frame the profit equation. What is that profit equation? Profit denoted by, which is again dependent on the units of production. So, is the total revenue, this is total revenue, and this is the total cost. So, this total cost T C minus total revenue T R, it is giving you the profit. So, if we just write in this form, P x is G x minus H x. G x is the revenue and H x is the total cost. So, as you have seen from the previous slide, G x equals to this, and the H x, the cost function, is this one. So, now we simplify this thing and we get that P x is this. Now, it can be rewritten like this: 8 into 10x minus x square minus the whole thing, this part, x cube minus 12x square plus 50x plus 100 whole divided by 50. So, now we are further simplifying, and finally, we get that the profit function can be expressed as minus x cube plus 4x square plus 30x minus 100 whole divided by 50. Now, you know, for the purpose of finding the break even point, as we have done in linear also, that the profit will be 0. That means, the total cost will be equal to the total revenue. So, here what we can do, that we can make this profit function equals to 0. So, minus x cube plus 4x square plus 30x minus 100 divided by 50 is 0. So, we can rewrite this: minus x cube plus 4x square plus 30x minus 100 is 0. This is our profit equated to 0. Solving this cubic equation, we get 3 values. One is x 1 is 3.0373, the x 2 is x 6.2395, and again x 3 equals to minus 5.2767. Since all these are in 1000 units, so I have kept it 4 decimal points to take a precaution. So, since products cannot be negative, so we ignore this value we ignore, and we consider these two values, x equal to 3.0373 and x 2 is 6.2395. There are two break even points at a lower. That means, if we multiply this with 1000, then say 3037 or 3038 is this number of units, and x 2 will be say 6239 or 6240. These both in both the cases we will reach the we touch the break even points. So, the curve is not linear, it is cutting the cost curve at 2 different points, that we will see also in the end of this. Now, the break even points are 2, 6.0373 and say 6.2395 or 23 even right 240, that is also possible. So, to get the maximum profit and maximum profit units, what we do? We go for differentiating the first order differentiation, the profit equation, and then we equate it to 0 to find out that, and then what we do, that we find the roots of this equation. This is what we have done. Now, check for the maximum profit or minimum profit. we go for maxima minima, the double differentiation to see the slopes of the profit equation. So, we have the profit equation, then we go for a further differentiation. So, check on the roots we get from the first order differentiation. The root on which we get the maximum profit is that is the number of our that will show the number of maximum profit units. So, we have to differentiate once again. Let us see one by one. So, we had the P x profit equation, this we have seen, and then we have done the first order derivative once here. So, by doing that and equating it to 0, we get 3 x square plus 8 x plus 30, and then we equate it to 0. On solving this equation, we get x 1 is 4.77 and x 2 is minus 2.1. The negative root does not concern us, as number of units cannot be negative. So, we need to check whether we get maximum or minimum profit at 4.77 thousand. Here this is a question of maximum minimum. We will just check it whether we are having the maximum profit or minimum profit, because this is where the slope is 0, it is taking a turn. So, find the first derivative, step 1. So, compute f dash x and set it to 0 to find the critical points where slope is 0, f dash x is 0. Okay. Now, then we go for the second derivative, like the compute f double dash x. Then we apply the test, like if x is greater than 0 at a critical point, then f x has a local minimum at that point, and f double dash x is less than 0 at a critical point, then f dash x has a local maximum at that point. Now, if it is equal to 0, then the test is inconclusive and then higher order derivative will be required. So, we have already found critical points. Now, we want to do the double differentiation to go one step ahead. So, we have this p dash x already found. Then what we do? We go for p double dash x, that means minus once again differentiate it, and we get minus 6 x plus 8 divided by 50. So, now we check at critical point 4.77, that means in thousands. So, this 4.77 we replace in place of x, substitute, and then we get p double dash x is minus 0.41. As p double dash x double differentiation is negative, this gives us the maxima. So, at this point we have maximum profit, we do not have to check others. So, by substituting 4.77, we get the point where we get the maximum profit. So, the maximum profit unit is 4.77 into 1000. So, it will be 4770 units. Now, to get the maximum profit, that means first we already got where we have the maximum profit, how many units will give us the maximum profit. So, from there now we want to quantify what will be the profit by substituting the value of x in the profit equation. In the profit equation, again we put the value of 4.77 in place of x, and then we get solve it and simplify, and we get 0.512. So, if it is in 1000 units, so the amount of profit will be 512, because this is 0 into 0.512 multiplied by 1000. So, this will come to $512, because both the cost and revenue equations are in $1000. Now, by substituting 4.770 thousands for x in the revenue and cost equation also, this is where we have used this 4.77 thousand 4770 units in the profit equation. So, we got the maximum profit amount from there. So, if you want to find the total revenue and the total cost involved for the purpose of for 4770 units, you can just substitute them in the equation and you can get that. We find that the total revenue is $3,992, whereas the total cost was $3,480. So, all components we have found out, where we got the how many units is giving us the maximum profit, and what is that amount of profit that we have made, what is the total revenue earned, what is the total cost incurred at that particular point, all have been found in this, and I have shown that step by step how to go and how to solve these problems. Do not go by these numbers here, because this is only for illustration, and to remind you once again, which we have seen during the theoretical discussion, that here the cost and revenue functions are intersecting at two different points. That means, this is the lower part. Naturally, we will consider this as a break even point, which is the lower one. Unnecessarily we should not think of this, but as you can see, when we are transiting from one break even point to another break even point, the curve is swelling. At a particular point, the slope is changing and changing towards lower side, negative. So, at that point we know that at that particular point we go for a double differentiation and see that at this point the slope is negative, and then we understand that is the point where we are getting the maximum profit. We consider that particular point as the number of units to produce maximum profit, and from there also we can calculate the maximum profit, and related to at particular point, this is the cost and this is the revenue. So, the cost and this is the revenue. So, both all the things can be found by solving this problem instead of graphically plotting it. You can use algebraic methods to solve, and using the basic calculus you can find out the number of points, at what points we are intersecting, and finding the break even points, then the profit point where we get the maximum profit. Now, we will be switching over to another set of problems related to depreciation, which was a big chapter, I think you remember. Here what we are saying that we have formulated a problem. A mining company purchases a high end excavation machine, for example, for 5 crores. The machine has an estimated useful life of 8 years and a salvage value of 50 lakh at the end of its life. The company decides to compare the written down method with 25% as fixed rate. Now, we are not calculating by 1 minus s by p raised to the power n, no. It is decided that we will be declining the thing using a written down method, which is fixed at 25% rate. Now, and straight line method, sum of the years method, and then compare, which is the suitable method, adopting their principles. So, and we can find out the depreciation using the techniques that we learned in the class, theoretical class, and then from the depreciation, then deducting the depreciation from previous year's book value, we can make schedules of the book values throughout the life of the mine for all these 3 methods, and then we can compare them physically, or at the same time we can graphically plot them to see how do they behave. Now, for say calculating the depreciation, let us remember the P being the cost of a machine, and S salvage value is denoted by S. Then for the life of asset we used N, and if D is the depreciation charge per annum, then for say straight line method we have D equals to P minus S by N. P is the cost minus the salvage value, whole distributed in n number of years. So, straight line, every year same depreciation will take place. But in written down method, or which we call the declining balance method, there will be fixed rate of depreciation, not the depreciation is fixed, it is the fixed rate of depreciation. So, it is the depreciation amount which is equal to B is the book value multiplied by the depreciation rate, or in our case it is 0.25 or 25%. For sum of the years method, depreciation amount is P minus S into remaining life divided by sum of the all years till end. Okay. And for every method, the book value will be taken as for that year, th year is the previous year's book value minus the depreciation amount. So, that will be the book value. So, we have all the depreciation and the corresponding book values. So, that if we find out all these things, then we can make the schedule of depreciation. Now, the written down method or declining balance depreciation rate given is 25%. So, the depreciation calculation for the first year is the book value, means the previous value multiplied by the depreciation rate, which is 25%. So, 5 crore into 0.25 or 25% is 1.25 crore in the first year itself. So, book value at the end of first year will be 5 crore was the price minus the depreciation that we have charged for the first year. So, at the end of the first year, the book value will be 3.75 crore. So, similarly, we can go on finding the depreciation calculation for each year. As I have shown, the 5 crore we started with, then the depreciation was charged as 1.25 So, the effective book value will be 3.75 crores, as we can see from here, that 5 minus 1.25 is 3.75. Now, in the next year what will happen, this 25% will be loaded on the book value. That means, the 3.75 is the book value in the beginning, which will be multiplied by 0.25 to get the depreciation. So, you get the depreciation by multiplying the 0.25 or 25% with the book value, book value for that year. So, now if we deduct again 3.75 minus 0.94, we get the book value at the end of second year. Go on repeating this for 7 years. So, at last you see 0.88, then you multiply by 0.25. So, 1/4 of that means 0.22 crore will be the depreciation. So, finally, it will become 0.66. So, in the last 8th year what we have done, that 0.66 is the book value, and then we adjusted only 0.16 depreciation. Instead of depreciating 0.66 again multiplied by 25%, what we have done, we have deliberately made it 0.16, so that finally we get 0.50 to equate with the book value, because we have not calculated with the existing given data, but we have calculated on the basis of pre-decided rate, which is 25%. Naturally, in most of the cases, like the depreciation, if you calculate by using the declining balance or written down method, you will see that the salvage value does not match, primarily because that in the calculation itself you have never used the salvage value. You have got the price or the cost of the machine when you purchased and go on multiplying and then deducting whatever the depreciation you are finding out from the book value. So, you are repeating the same process, and in the whole process you have never used the salvage value. So, at the end, when the book value is coming which is different from the salvage value estimated, then we deliberately equate it to 0.50. So, this is where you can see the beginning of the book value, beginning book value for every year, and then depreciation for every year, and ending book value at the end of the financial year, we get this thing. These are the book value of the equipment here. Now, we are changing the method. Straight line depreciation method is very simple. What we do that we deduct the 50 lakhs salvage value from the 5 crores and we get 0.5625 crores by dividing it by 8. So, now this 50 lakhs is 0.5 crores. So, 5 minus 0.45, 4.5 divided by 8, that will give you 5.5625 crores. So, in the beginning we had the depreciation first year is 0.5625, and in the the book value accordingly will be reduced. 5 crore minus 0.5625, you get the book value here. Similarly, you go on, every year you have to depreciate same amount and the book value goes down, 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 and since it has taken care of the salvage value, so at the end of the 8th year it is absolutely equal, just equal to the 0.50 depreciation. But here the depreciation is flat and it is a straight line method depreciation. Now, we are going to another method, sum of the years digit method, that that the multiplier, the factor that we use for the purpose of calculating the amount of depreciation is done by where the numerator is n life remaining life divided by the sum of the number of years. So, that is the factor that we use. For example, sum of the life is n into n plus 1 by 2, where n equal to life in years, 8 years, and sum of the life is 8 into 9, just we have calculated n into n plus 1 by 2. So, sum of the years digit is 36. So, the depreciable amount is 5 minus 0.5, which is 4.5 crore. So, what we do, the depreciation amount each year will be the 4.5 crores, for example, into remaining life divided by sum of the years. So, the cost of the machine, for example, 5 minus 0.5. So, depreciable amount is 4.5 crores. This we have to depreciate in the book of accounts. What we do, that every year we use a factor which is the n is the remaining life, and then the sum of the year digit method, we just use this formula and go on getting the depreciation amount. Now, in the first year, say remaining life is 8 years full, so it will be 8 by 36. So, it will the ratio the factor will be 22.22%. So, we get 4.0. Similarly, we for next year we have 7 by 36 and we get 0.875 and it is 3.125 book value. That means, we deduct it from 4, the book value was previous year is 4 minus 0.875, we get 3.82125. We repeat the process every year. You just see here in the 5th year we have 5 years remaining and 5 divided by 36, we get 13.89, and then we get 1.75 as the book value, and this is the depreciation amount. Go on doing this. Since you have taken this this thing your salvage value into account, so it is matching here. It is matching here 0.50. Now, we have a whole lot of depreciation amount here and corresponding book values on the other column. So, this schedule is ready. Let us plot now all the values that we got over the years up to 8 and book value this side. Okay. First one is the straight line method. As you can see that every year it is falling at the same amount, and then that is why the depreciation the book value rather plotted are simply linear. it is linearly depreciating, linearly. But if you see the double decline balance, in the first few years you see it is sharply declined and then it becomes slowly flat here. The first part is very sharply declining. Some of the years disease is also behaving similarly, even though in the first few years the decline is not so sharp as you can expect from the double declining balance method. So, what we can see, three different methods in the same plots, depending on the policy that the company adopts and also depending on the item that you are trying to find out the depreciation about, then the depreciation does not only depend on the policy of the company, it also depends on certain guidelines given by the government for those particular items. At the same time, what items actually you are depreciating? I mean, is it computers and stationaries, or say chairs and tables, or buildings, or you are depreciating equipments. So, depending on that type also we decide. So, if for example, in equipment in the beginning we try to use the double decline balance methods, others where it is fully utilized throughout the life, we may prefer these things where the service is meaningless here. But here the service is very much meaningful, that in the beginning we fully try to utilize the services and we try to depreciate. So, we get more output in the beginning and less maintenance. So, we go on depreciate very fast. So, we use the declining balance methods for equipments most of the cases. I hope I could make this concepts clear by considering all of them together and plotting them together also. For reference purpose, you can use this very book, very good books. One is the this one, Practical Guide to Depreciation under Companies Act. This is Indian author and it is very relevant, very relevant. And also in the beginning we have used this break-even analysis article, which is old, but the concepts are absolutely in those days it was new, but the similar thing we nowadays also use. Same, the basic ideas are same. So, this is a very good article, you can easily find out from the internet. With this we come to the end of problems and solution about the break-even analysis, at the same time the depreciation, and in the next we'll take some more examples for the other topics. Thank you.